Today we'll be looking at the MOIVRES theorem proved by mathematical induction. From our knowledge of mathematical induction today, we are going to prove that for any rational numbers n, the value of the cos theta plus I sin theta raised to power n is equals to cos n theta plus I sin n theta. As we all know that this basically is the MOIVRES theorem. I guess we all know that. Now I want to prove that this is equals to this. And now from our principle of mathematical induction, we know that we have three proofs in mathematical induction. The first proof is prove true for n equals to 1. Second proof is assume true for n equals to k. And third proof is prove true for n equals to k plus 1. Don't worry, I'll do that below. Now we go into proof. Now let's start with case 1. That is what? Prove true. I'm not comfortable with blue. First stage is prove true for n equals to 1. Prove true for n equals to 1. Now let's now write our equation. That is, we want to prove this. Cos theta plus I sin theta raised to power n equals to cos n theta plus I sin n theta. Then anywhere we see n, we put our 1 inside. Now let's go by saying open bracket cos theta plus I sin theta raised to power 1 equals to cos open bracket 1 theta plus I sin 1 theta. Writing our answer, we are going to have cos theta plus I sin theta equals to cos theta plus I sin theta. That is, here is equals to this. Therefore it is true for n equals to 1. We have proved it. Now let's go to case 2. We're looking at case 2. Now case 2 is assume true for n equals to k. That is the second rule in principle of mathematical induction. It's not a made-up thing. Now let's write it. Assume true for n equals to k. For n equals to k. Now this means anywhere you see n, you put k into it. Now let's start by writing our formula. We have open bracket cos theta plus I sin theta raised to power n equals to cos n theta plus I sin n theta. That is, anywhere we see n, we put k into it. Now let's start by saying open bracket cos theta plus I sin theta raised to power k. That is, anywhere we see n, we put k into it, equals to cos k theta plus I sin k theta. Using this, as we all know that when we have cos theta plus I sin n theta raised to power k, the k comes into it to be cos k theta plus I sin k theta equals to cos k theta plus I sine k theta. Now we can see that the left hand side is equals to the right hand side. That is true for n equals to k. Now let's go to the final case. That's case 3. And case 3 says that proof true states, case 3 states proof true for n equals to k plus 1. This is gonna be a bit complex because we're going to add our knowledge of trigonometry into it and any knowledge you can find. Now, third case, proof true for n equals to k plus 1. That is, anywhere you see n, you put k plus 1. Now, right now our equation, we will have open bracket. Let me start from the top so it will be easier. We have cos theta plus I sine theta raised to power n equals to cos n theta plus I sine n theta. Now, anywhere we see n, we put k plus 1. Now we're going to have open bracket cos theta plus I sine theta raised to power k plus 1. That is, anywhere we see n, we put k plus 1 equals to cos k plus 1 theta plus I sine k plus 1 theta. Now what we got here is cos k plus 1 theta plus I sine k plus 1 theta. Let's leave this as this. That is, we want to make the left hand side equals to the right hand side. Now we are going to leave this part alone and deal with this part. Okay, now our aim is to make here like here. Let's do this together. We're going to have cos theta plus I sine theta raised to power k plus 1. With our knowledge of indices, we can open this to be cos theta plus I sine theta raised to power k dot cos theta plus I sine theta raised to power 1. Yes, I hope this is open and clear to us. Now, with this, we are going to have, let's open here first. We're going to have cos k theta because of this k above, and we all know that when it's entering it turns to the next substitute. It just, when coming down, it turns to cos k theta plus I sine k theta, not cos square k theta. No, that is not allowed. Now dot what, side bracket dot cos theta plus I sine theta, because this is raised to power 1, it just give us the same thing if we try it. Now let's start by multiplying both sides by like opening the brackets. Now with this will times this, and this will times this, this will times this, and this will times this. I hope you all know. Now let's start this multiplying this. That will be cos k theta times cos theta. That will be cos k theta cos theta plus cos k theta times I sine theta. That's cos k theta I sine theta plus I sine k theta cos theta. That's I sine k theta cos theta. Then our last one is I sine k theta times I sine theta, that's plus I square sine k theta sine. Okay, let me write it below. We're going to have I sine k theta sine theta. They are together, as we know. I sine k theta sine theta. Now let's let me write this. Oh, no space. We are doing this, the last one, this times this, that's I square sine k theta sine theta. Now we all know this is the real part, this is an imaginary part because it still has a sum constituent of I. Okay, let me try making it meaningful by saying cos k theta cos theta plus I'm bringing this I out, plus I cos k theta sine theta plus I sine k theta cos theta. As we know that I square, in complex number, I square is equals to -1. That's what minus sine k theta sine theta. Let me try putting a partition to know the parts we are working on. Yes. Okay. Now I hope we know that this here is sine k theta sine theta. Now what we got here is cos k theta cos theta plus I cos k theta sine theta plus I sine k theta cos theta minus sine k theta. No, minus sine k theta sine theta. That got erased when I did that. Okay, now let's bring in our firstly let's arrange them in both real and imaginary parts. That is, let's put them into brackets. Firstly, this is a real part, it doesn't have any constituent of I. This is an imaginary part, it has I. This is an imaginary part, it has I, and this is a real part, it doesn't have any constituent of I. Okay, let's go. Now let's group them into real and imaginary parts. Here we're going to have cos k theta cos theta minus sine k theta sine theta plus I open bracket cos k theta sine theta plus sine k theta cos theta. Let me try rewriting this, just having some space issues. Now we're going to have cos k theta sine theta plus sine k theta cos theta. Yes. Now we have grouped them into real and imaginary part. This is a real part, this is an imaginary part. Okay, now moving to our knowledge of trigonometry. As we all know that when we have, okay, let me just skip this and move to the law of trigonometry, which says when we have let's get this once and for all. When we have sine a plus or minus b, our result is going to give us sine a cos or minus cos A sine B. And same thing as when we have cos A plus or minus B, it gives us cos A cos B minus or plus sine A cos B. Let's not forget this. No, it's plus or minus, no, it's minus or plus sine A sine B. This is the law. Let's not forget this. Law. Now, looking at this law, let's look at this part. We have cos K cos theta minus sine K sine theta. That is also related to this. No, not to this. Related to the one below by cos A cos B minus or plus sine A sine B. We can see it's related. And when we have cos K theta sine theta plus sine K theta cos theta, we see it's related to this. Okay, now let's just jot this down. I'm going to erase it now. Okay, now I'm erasing it now. Now let's now apply it into what we are solving right now. Okay, now we know that cos K theta cos theta minus sine K theta sine theta, as we all know what it's going to give us. It's going to give us this will be simplified to, okay, with this color, this will be simplified to simplified to cos open bracket K theta minus theta, cos of this K theta here, cos K theta minus theta plus I open bracket plus I sine, this will be simplified to sine K theta plus theta. Let's not forget that this is also equals to this here. We just left it because we want to make this like this. Let's not forget that. Okay, now we have done this. Now let's now simplify it by saying, okay, we can see theta is constant here and constant here. We can still bring it out. We're going to have cos K. No, let's bring theta out. Let's say cos K plus 1 theta, because theta entered to give us cos K theta plus theta. K plus 1 theta plus I sine, let's do the same to this side, I sine K plus 1 theta equals what we have here. Now as you can see that this is equals to this. Now let's now write our final answer out. Sin cos K plus 1 theta plus I sine K plus 1 theta is equals to cos K plus 1 equals to cos K plus 1 theta plus I sine K plus 1 theta. Now we can see that the left hand side is also equal to the right hand side. We have tried both the first case, proving the first case so that it was correct, second case correct, and the third case we can see that it's correct. So far the left hand side is equal to the right hand side. I hope this was simple and straightforward. Thanks for watching, and if you have any problem, just write it in the comment section. I'll look up to it. Thanks for watching. Like and subscribe. Thank you.